All right. Good morning, everyone. How are you doing? You're all excited? I mean, this is a wonderful place to be at, right? Okay. Continuous PHP pipeline. Just a question around. Is there already someone here that has absolutely no idea when I'm talking about continuous integration? Please raise your hand. Because it's all about quality, continuous integration, those kind of things. So if you're not familiar with it, it's gonna be a little bit tough to follow along. But if you do, stick with us. Who am I? My name is Michelangelo van Dam. I'm a PHP consultant, mainly focused on quality assurance and improving workflows. I'm also a community leader. I'm president of PHP Benelux. We have annual conferences and monthly meetings. So if you're in the Belgian area and you like to hook up with the PHP community, come to us. We're also supporting all the localized communities within Belgium and the Netherlands. And of course, Luxembourg. If you are interested in PHP training, come see me after the show, and I will gladly inform you about our training opportunities. So today's schedule. We're going to talk about the development processes at first. Then let's have a look how we can automate these things. Of course, continuous integration. And then we come to the nice part where we're going to put everything in a pipeline. And we leave you with what you do best, namely coding. And of course, we have a roundup, and you can do it. Okay, just a knowledge check. Is there someone in the room that doesn't know what PHP is? Yes, okay. Well, PHP is just awesome. You will see during the show. When I ask about SCM, anyone can give me names of an SCM? What? Sorry? Git? Anything else? Mercurial? Anyone using subversion? There you go. Respect for you, sir. When I talk about unit testing, is there a PHP framework out there that you guys use? What? PHP unit, someone? Okay, half the room. Atom? A couple of people. Simple test? Ooh, non-takers. Okay, yeah, that can happen. Distributed systems. Is there someone using cloud infrastructure here? Amazon, AWS, Azure, Rackspace? Yeah, okay. Provisioning. Is there someone using Puppet or Chef? Puppet, yeah, Chef. Sorry? Okay. There's also this new thing called Ansible. Pretty awesome. Yeah, see a couple of people here. So, okay, you guys are familiar with this. Who had to deal with merge conflicts in, let's say, the past 48 hours? Okay, so everyone is doing a good job. Awesome. All right, well, I come a lot to these companies, and they have a team of developers. And above these team of developers is, of course, management. And when we talk about development management, we talk about, of course, waterfall. Who uses waterfall in their projects? Ooh, no one. Okay. Well, maybe I'm just unlucky to be at these companies. Who uses Scrum? Ooh, a lot more. So everyone else that didn't raise their hand is probably doing something, right? Okay. It doesn't matter what kind of approach you have, but one of the major things is you need to deliver. So when I talk to these developers and they go like, hey, we need to have something up in production, they call it an event. Who's calling it an event? Here, no one? So you're not doing like off-hours release planning. You're not doing any maintenance page setup. Wow, impressive. Okay, this is completely the wrong audience I'm talking to. Well, in my case, I have to go through all these things. There's pre-release actions, a release backup checklist. Then we have post-release actions. We need to remove the maintenance page, which is often forgotten. And then we have to verify everything is working, and basically using a browser and go through every single page. And if you're lucky, you can go home for the night, or even in most of the cases before morning shift starts. As you all can see, this is typically a nightmare, right? Okay, so what we do first when we come to these development teams is, let's see how we can automate this thing. Because computers are great at doing very repetitive tasks very well. And when you look at an application, you basically have like 3 major blocks. First, you have your infrastructure. You have a platform. And last but not least, you have the development. The infrastructure is basically decided on, okay, how the business runs. So it can be on-premise. It can be provided by a hosting company. Or it can be up in the cloud, right? And then you have a simple architecture, right? So you have a web application and you have a database. And then the application grows and grows and grows, and your simple application architecture becomes more like this. Are you prepared for that? Are you ready? Because I see a lot of companies growing so fast with a lot of competent experts on staff, but the fast pace and the complexity of the multi-tier environments overwhelms the engineers. And it makes the business unable to cope with the growth. So when you are working on a project, when you're working on these kind of things, you need to think about getting everything automated as quickly as possible. So when we look at the platform, there's a whole bunch of automation tools that you can use. And we already discussed this, but let's go over it here. So we have the GNU shell, of course. Ansible, Puppet, Chef. Is there anyone using Thing here? Okay, I see a couple of people. Then you have Ant. Any takers? Okay, just a few. So these automated elements are very easy to implement, and they allow you to build a system that runs the same way for everyone, whether it's for the developer, whether it's for the QA team. Oh, my bad, my bad, my bad. Yeah, I forgot the one-on-one on speaking. Turn off your cell phone. Sorry, my bad. So when you have these automation points in place, your development team operates it the same way, your QA team operates it the same way, your support team operates it the same way. And also when you have to release it, it will always be in a repetitive, automated fashion. And that allows you to improve the workflow that you can have in order to get these products into the production environment. So I always get this question, but why should we automate this? Well, your application is unique. Your application is completely different than from the guy sitting next to you. So if you have the project up and running, it might be using different components, different attributes compared to the application of your neighbor. So if you can script this and you can run Thing on the command line, well, it's nice because now it can be deployed automatically into the production system. And this is something that you can share with your neighbor sitting next to you, because he will probably use thing on the command line as well, or end for those few using end. Because you have developers working on new features, working or fixing bugs on the application. Why wait until everything is ready and package it up into production? Now you have this tool in place that will automate the whole procedure and will allow a developer to commit his code and push it straight into production. So that's one of the other benefits. When you have your architecture in a consistent way configured, it allows you to immediately spin up a stage environment and allows you to have an acceptance environment. And once everything is done, you can push it immediately to production, because the environments will be the same for everyone. But of course, you need to choose wisely. There are many options out there, and some of these tools are very good for Unix environments and not so good for Windows environments. So you really need to look at, okay, what is the majority of our development team or our product team working on? If your developers work on MacBooks or on a Mac machine, and the QA team works on Windows machines, using Ansible can have a couple of challenges. So you prefer to use something like Puppet or Chef. But since a couple of years, there is a new player in town, and it's called Docker. And Docker allows you to completely remove the virtualization software, because now it runs natively within the core of your application system. The only downside is, as far as I have found out, is only running on Linux. So if you have a different environment, it might be challenging to get it set up. But of course, you can have one virtual machine and use Docker, because now you can have every system that you have in place using its own container, so you don't have to worry about, oh, my development environment is on one single stack, while production is using a full multi-tier environment. So, who uses Vagrant up here? Okay, awesome. So with Vagrant, no matter what kind of technology that you use, what kind of provisioner you use, you have your infrastructure up and running in no time, right? Then you go to development. SCM is a must. I mean, we talked about subversion, Git. Someone using the Team Foundation, Microsoft? No? Oh. It's not bad. It's not good either, but if you work on Microsoft, at least you have something. Bazaar, anyone? I see a Lone Ranger up there. And I also heard mercurial. FTP is not an SCM. I'm just saying. I've been going to a lot of these companies, and I look at how developers do their development, and they actually have folders, version 1, version 2, version 3. And then they use FTP to manage it on their production environment. Yeah, it works if you're a Lone Ranger at the company. The moment you have multiple developers, it's not going to work anymore, because you will override your own changes. So, in a more up-to-date kind of SCM, you have this kind of approach. If you're using Subversion, basically the blessed repository will be your Subversion server. Your developer works privately, offers a public change, Either it's a commit to a feature branch, or it is something that you offer as a pull request. Then you have the integration manager that verifies it, do some code coverage reports on it, does some code reviews, and when he agrees, he pushes it into the blessed repository. And from that point on, we have infinity ahead. And then this is the nice thing about continuous integration, because now the moment it is up in your blessed repository, your CI system can take it over. It can just look at the source code and say, okay, this is something new. Let's work our magic on it. So why CI? Well, first of all, it monitors your code base continuously, right? And because it monitors it continuously, it allows you to, to make a change, push it to the repository, and bang, it detects the change and starts working its magic. And it automatically gives feedback if something goes wrong. You don't have to do anything about it. It will tell you something is broken. And most of the CIs have dashboards. So if you have a manager that likes to see some nice graphs, you can just pull out the CI dashboards and present the graphs to him. So they're happy. And it allows you to do a lot of automation after everything is verified and everything is considered satisfied. So let's have a look at, you probably know this, but you have some pre-built steps. One of the things that we do is, okay, we shut down the crons, we clear the queues, workers, and if possible, we remove the target from a load balancer. And this is all automated. So that system is no longer reachable. We have the build steps. We check out the new changes. We run our unit test. Everything is okay. We provision our targets. We provision our databases. And once that is complete, we do the post-build steps. We warm up the caches, reactivate the crons, queues, and workers, add the target back in the load balancer, and we send the status out. And this is all happening completely automated. So if you're wondering, how can I get started with CI? Yeah, well, these are the tools that you can download. Jenkins, Bamboo, which is a non-free version for Atlassian. If you work with Jira, you probably have seen this come by. Who uses PHP Storm here? Okay, Team City is from the same developers. It's a JetBrains product. You definitely want to check it out. It is very fast, very informative, something you might want to check out. If you don't want to bother with setting up a CI system for yourself, you can have a look at online CI systems. You have CodeShip, Semaphore, Circle CI, Travis CI, probably the most known if you're on GitHub. Continuous PHP, and by the way, there's a couple of people from Continuous PHP. Please stand up. If you have a question about Continuous PHP CI integration online, talk to that guy after the session, and he will be able to answer all your questions. And of course, with CI comes some additional tools that allow you to inspect the quality of your applications as well, also online. So when you look at it, you have a dashboard. And dashboards are very nice for managers. It gives the feedback directly to your developers. It also gives you direct feedback to the managers or the development leads. Because I can see here, everything is okay. It took less than a millisecond to execute, and nothing is broken. So for me, that is an assurance that everything is okay. If you use an online system, it uses the same systematic approach. Everything is green. You have a nice success status, and it will give you a report about, okay, how long was the execution time? If you go for more quality stuff, this is from coldclimate. It does a complete inspect of your code base, and it will provide these nice badges. If you have a open source project, you can put it out there on GitHub. It's always nice to have these badges in your README file. Continuous PHP is providing the same interface. All you need to have is a status saying everything is okay, and giving the code coverage is a bonus, just like that. What is the most important part of a CI? It's about the feedback it gives to the developers. Not about what's basically on the dashboard, but you as a developer need to know, oh, I screwed up. And this is where the PHP pipeline comes in. So when you're developing applications, it's not just the code and then put to production. There's a whole bunch of things that come into play. One of the things is I need to run my unit test. I need to have some metrics on it. I need to provision a new target. I need to provision workers. I need to provision my databases. We have some integration tests, and then we promote the branch. And with promote the branch, it can be released to production, or it needs to go to the next phase, like acceptance or whatever. And I want to be known, or at least I need to have the information the moment something breaks. So when my unit tests break, it needs to stop immediately. And the same goes for my metrics, my provisioning. If something is wrong with my provisioning, it needs to stop execution and report as quickly as possible. Because if a developer needs to wait, let's say 2 hours before one of these feedback comes in, he's probably doing something else. And he's more reluctant to quit what he's doing to fix the problem he faced before. So the sooner you can provide this feedback, the quicker it can be resolved. So when everything is good, you can actually promote stuff. And because the SCM systems have this functionality already built in, it is easy to say, okay, we now have everything provisioned. It's on our test environment. Everything is successfully processed. Let's move it to the next level. And the next level can be, let's deliver it to our QA team for acceptance. And it goes through the same approach. Or you can have a different build pipeline right there. And this allows you to fine-grain the whole delivery of your code from finishing the development all the way to delivering it into production. Is there anyone here in the room that knows the difference between continuous delivery and continuous deployment? Yeah, you're not allowed to speak. Ma'am? No? Okay. The continuous delivery, the aspect is, oh, there is a manual step. You have a final step, final improvement before stuff goes into the production. Continuous deployment means everything just goes automatically. And in our situation, we tend to have this because once everything is automated, there's no need for a final approval before stuff goes into production. To have put it in a more visual environment, your developers commit to SCM. The CI sees, oh, there is a change, pulls it in, gives feedback, has a feedback, goes to the deployment management dashboard, and there you have a set of buttons, and someone can say, this goes live now, this goes live now, this goes live now. Yeah, managers love this kind of buttons. You can even have a USB button on the manager's desk, so he just have to punch it, and stuff can go into production. Hey, if you want to treat your manager well, it's a nice gift for Christmas. So things can go to test, to staging, to production. Like I said, we used to do this, but it was so cumbersome because all of a sudden the manager was in meeting or the manager was on holiday. So we just skipped the whole management part and said, okay, everything is cool, let's put stuff in production. And we decided all our code should be in production. All the code is live. And I'm not sure if you can read it all the way in the back, but if you have an application class that has a method to fetch a feature and to verify is complete, then here comes the new feature functionality. And all of a sudden, the moment it is flagged complete, it's out there. And you can have multiple implementations for this. It can be on your controllers, in your views, on the business logic. So in production, it will be hidden. Everywhere else, the feature will be accessible. Why? Because all the developers can depend on it. There's no way that a developer has to wait until one project is finished. No, because the project is already available. So there is no wait time anymore. Other things that we also do in this approach is A/B testing. We can do partial rollouts based on geolocation, age, gender, which is also nice. If you're working on a SaaS platform, it allows you to deliver premium features for a specific group of customers, like VIP customers or something. If you have a training program in your company, you can have automated training exercises based on this. Is there someone in the room who heard of the Netflix Chaos Monkey? Okay. If you don't, look it up on Google after this session, please. It is a tool developed by Netflix. It's open source now. And what it does, it is about resilience testing. So how resilient is your application when system starts failing? If you're not sure, just try it out on your system. Do it first in test environment and see how resilient your application is. We now have the Netflix Chaos Monkey running in production, and we have full control over it during office hours. So it starts kicking off systems out of our load balancer. It starts removing instances from our clouds. It does that. And if you don't design for failure, you will be in big problems. With the Netflix Chaos Monkey, you can identify these problems and start working against it. And this allows you to have a better resilience of your web application. So something you really want to check out. There's a link right here. Who's doing April Fool's jokes in his company? Okay. We use this specifically for managers, so all of a sudden we have an application completely reversed or something like that, and then they go like, something is wrong. We like to play around with our code base. We have a small flight simulator. It's not really fancy-pantsy like Microsoft Flight Simulator, but we had the flight simulator built in, so the moment that the manager came to our application, all of a sudden, Flight Simulator started playing. Pretty awesome. So yeah, you can. This is just a list that we do, but if you're very creative, you can make it double or triple the size of the things you can do with it. The goal is basically that you, as a developer, can focus on the stuff that you're doing. Because I like to sit at a pool. I get a complaint, something is not working, I fix it, and the fix is immediately in production. Without me having to worry, oh, I need to spend the next 4 hours trying to solve a lot of other issues. I can be in my hotel room, like this night, fixing some stuff. I can be in my car, pull over, start fixing something very urgently, and I don't have to worry. I'm not sure if you can see it, but you have these elements. We have a success after 3 minutes, 49 seconds. That's 16,000 unit tests. Okay? So, for 16,000 unit tests, less than 4 minutes, not so bad, I think, right? Don't forget, failures do happen. So, someone committed something, the refrigerator issue. Jenkins took it over and reported a failure after 32 seconds. So, in less than a minute, he was already aware that something was completely broken. He noticed it, fixed it, and after 32 seconds he got, okay, your problem is solved, move on. That is the kind of feedback that I prefer to have as a developer. Very quick feedback. I commit something, bang, you did something wrong. I hate to be wrong. Trust me, I hate it. But I'd rather know it instantly that I'm wrong than hear it afterwards. Especially when customers start calling, hey, it's not working. Then I really feel ashamed. Our tools? Yeah, we're hardcore. We still use Subversion. We use Jenkins, Vagrant, we use Puppet, VirtualBox, Fabricator. Anyone knows this? Yeah, a few. For those who don't, it's a tool designed by Facebook developers for code reviews and managing your projects. If you don't use such a tool, go check it out. It's pretty awesome. It's fully featured, and I cannot live without it anymore. We use Jabber for internal communication. You can hook it up with HipChat and Slack, and we also use Slack for communication, as you could see, and it works brilliant. Some of the stuff that we do, yeah, we have a total of 129 commits on average. That was on Friday, last Friday. We release 118 times. We get about 11 failures. It's not bad, considering the amounts, but it's still not good, in my opinion. We have automated DB deployments 4 times a day. We have a failure resolution time of average 5 minutes, which is pretty fast. And the average release time, it takes about 3 minutes. Just to give you an idea about how automation can really move things forward. So I see that we're getting close to the end. Let's round up. It's your turn now. If you're a coder, automate everything that's not code, okay? You don't need to have any process manually after writing your code. Create repeatable, reliable processes. Okay, and that makes a lot of sense considering. Fail as quickly as possible. So always make sure that you fail first and then move on to the next level. If you do coding, you probably also have the same approach. So also in the automation part. Communicate each step. So, okay, we have now run our unit test. We now go to provisioning of the caches or something like that. Just make sure that that communication flow is very transparent. Also, in your team, everyone is responsible. Make sure that every developer is capable of fixing someone else's mistakes. The reason why that is someone is on an airplane at 10,000 feet, commits the code, signal gets lost, and yeah, okay, now something is broken. Someone else needs to fix it ASAP. So make sure that everyone on the team knows how to fix each other's code. You can do this through peer programming. You can do this by having weekly sessions about what's been developed. But everyone should be able to fix each other's code. And continuously improve. You will improve on your code. That's why you guys are here. But also on your processes. Your processes can be automated. Everything that is not code related should be automated, in my opinion. If you want to read more about this, I can really recommend this book. It's Continuous Delivery by Jess Humble, David Farley. Who knows about Martin Fowler? Okay. If you don't, you probably need to look up that name. He's like the godfather of computer engineering. And it's part of the Martin Fowler series. So all I have to say is keep calm, release more. If you want to contact me, my contact information is right here. I'm also on Joined In. The slides will be uploaded after this session, somewhere during the day. Please give me feedback on this talk. If you liked it, thank you very much. If you didn't like it, tell me why you didn't like it and how I can make sure that the next time you will see this, you do like it. And that's about it. You have questions? Yes, sir. Oh.
How do you manage database migration and provisioning and so for continuous integration? I think database is one of the big problems.
Well, the database migrations is always challenging. What we use is DB deploy. It's not a application. It's more like a principle. It's fully supported by Fing. I'm not sure if Ant supports it out of the box, the procedures. But what we do is we keep a track of deltas. So we start off with a schema in our database, and every change on that database is considered a delta. We put it in a delta file, so it's an alter statement or an create statement for a new table element, and we provide it with numbers. DB deploy, the principle is, okay, let's look up the latest committed number in the database, verify it with what's on the file system, and we take everything that's after that number. It will execute it. If it's not working, it will revert back. So if something fails during the release, it will roll back to the latest state. And it will, of course, report that something failed. Is that a good answer for you? Yeah? Okay. Any other questions? No questions? Wow. Oh, I see one there in the corner.
If you use subversion, you cannot do really pull requests like in Git. How do you interact with big features, which you would normally put into a pull request and only then merge?
With subversion and pictures?
No.
Okay.
Okay, I'll try again. So if you have a really big feature and you don't want to merge it into master or trunk, depending on your version control system, in Git, we would normally put it into a pull request and work on it there, and then someone can review it and merge it in if it's done. How do you do that with Subversion?
Okay, so with Subversion, we still branch. So everyone works on a branch, a feature branch, whatever. The feature is live from day one. But we use that approach that I displayed on screen, right? So the feature is available for all the developers, but it was developed in a feature branch. The moment that we are considering the feature to be complete, it will be merged in the trunk with Subversion. And of course, we have the configuration setting that particular feature is now active. So it all merges into one integrated system.
Okay, so you only use feature branches with subversion as well?
Yeah, depending on the customer, most of the time we're not actually doing versioning because it makes no sense. There is no particular version of the application. The application just grows organically. Some of the startups, they do want to have some versioning, so we use tags. But it's basically when we hit a particular milestone on the project map, and then we decide, okay, this is version whatever, and then we upgrade. And then, of course, we have version branches. So all the features that are being put in a feature branch will be merged into the version branch. Yes?
Okay.
Okay. Any other questions? Yes. A few rows back.
Do we have a different CI process for example, if the feature concern the front end fix a CSS file or something like that? Do you run your CI process with test and waiting 3 minutes just for a fix in the statics file, for example? Or do you have a process more quickly?
Well, we do have CSS lint and we have JS lint, but they are considered to be pre-commit to hooks. So basically, it's already validated before it actually enters the repository. So the CSS, the JavaScript elements on commit gets first validated, and then if it's valid, it will be accepted into the repository. So it's not part of the CI system, it's part of the commit system.
Okay.
Okay. Any other questions? No? Okay, well, thank you very much. Enjoy the conference and see you around. Bye-bye.